Hey, you are watching Cloud and DevOps Z Days, and while all the people around the world are trying to keep the safe self-isolation and to keep social distance, you have this brilliant opportunity to attend online event and know something new. So during the session, I want to encourage you to ask questions in the chat and vote for the most interesting questions on your opinion. And the best one will be able to get the very special prize at the end. So without any additional words, let me pass the microphone from here, from Kiev, Ukraine, to the Dnipro city, to the Dnipro Batievsky, who definitely know more a lot of service mesh, why and how. Hello, Dmitro.
Hello. Hi, guys. Thanks for watching. So, we will be talking service mesh, why and how today. Let me just, yeah, so my name is Dmitro. I'm on position of systems architect here in EPAM, Ukraine. I have started working with Kubernetes long before version 1 was released, and hear a lot of service mesh noise around here and there, and the technology is being talked about so much and becoming increasingly popular. But really, I see a lot of people and organizations who don't have clear understanding of which exact benefits service mesh can bring to their development experience, to their operations, and also, yeah, so agenda for today, we'll start with service mesh concept and then continue with features service mesh provides and typical patterns of how service mesh is being used, and then proceed to short overview of service mesh market. Okay, so let's go. And yeah, I guess questions will be asked after I finish, right? So there will be no interruption. Okay, then. Let me just move this here. Hope you can see the screen, guys. Okay, so what's service mesh, right? The basic idea behind service mesh as they emerged was that you need this proxy next to each container you are running, or so that you can control network traffic, and all that. So basically some terminology here. So I'm assuming you are familiar with Kubernetes and know what is pod. For those who don't, pod is one or more containers running together, right? And being treated as a single object by Kubernetes, because containers were designed to run one process per container. There are still situations when you need to run several processes, right? So in that case, you run several containers and link them together so they form a pod. So basically the idea is that all network traffic only goes through proxies, right? So you have the so-called sidecar container with a proxy running with each pod or container, and all network traffic only goes through that proxy, right? So your application running in a container will not be communicating directly to anything, by anything I mean anything, right? So it will not reach to other services running on the same cluster. It will not reach to any internet domains or something. So it will only be communicating to this proxy, and this proxy in turn will be doing all the required network communications on behalf of your application. And then it's distributed, right? So here on the diagram, we have just two pods, but in real life scenarios, in production Kubernetes clusters, you will see typically hundreds of thousands or tens of thousands of pods running, right? So each pod will be accompanied by this sidecar proxy. And really key piece here is control plane, right? And that control plane is what makes service mesh, right? So this control plane is a central point which is responsible for running all these proxies and managing their configuration. So it's a single pane of glass. So you have that central interface where you manage all your network policies, configurations, any settings needed, and this control plane takes care of actually applying those policies and rules and configurations to all these proxies. And then basically that's it, right? So idea is simple. So let's have this sidecar proxies, as many as we need, and then let's manage them through the control plane, a central place. And piece to understand here, these proxies, they will not be like, of course, it's all immutable, right? So assumption here is that you're following immutable infrastructure concepts, and you just dispose your pods or deployments or replication controllers once you don't need them. Okay, seems simple enough, but well, here we start with why, right? So how traditional application looks like. So there is a service, as you can see on this diagram. A service might be running as pod on Kubernetes or might be running on a virtual machine. And then this service can be anything, right? It can be API service or can be backend, front-end, middleware, whatever, right? So it runs somewhere, and traditionally it will have all the network logic, all the logic related to metrics, security, login, whatever, right? So a lot of non-business logic will be on that service, and that really takes a lot of effort, right? So if you had an experience of running like microservice platforms with hundreds of services, you know that this really takes time and effort to manage all this, right? And especially edge cases with different languages, like, for example, if service on the left is implemented in Java, then service on the right can be implemented in PHP or something else, right? C#, whatever. And it's hard to find libraries which will do exactly the same across different platforms or languages, right? So in multi-language environment, it becomes increasingly difficult and sometimes impossible to maintain same rules, across the services. So why not outsource that to something else? And that's where service mesh idea comes in, right? So with service mesh, you have this sidecar proxy, which is designed to handle all that non-business logic, right? You kind of source non-business logic, let's say network-related business logic, to that sidecar proxy, and that will be managed centrally, right? One clear benefit here is this uniform proxy, and it's it's the same piece of software that can be deployed with any service written using any programming language or framework, right? So for standardization, this is extremely good. So you have same piece of software across your platform, regardless of runtime, language, operating system, whatever. Which has same capabilities and same logic, right, and follows same rules. And it's centrally managed, right? So you can manage all this praxis with that control plane. So when we go to use cases, the most voted for features would be security. Right, so very popular feature, extremely useful and saves a lot of effort. So mutual TLS. This can handle authentication and authorization in addition to network policies, right? So I'm assuming if you are running your workloads either on Kubernetes or on VM, you will have some sort of network policies implemented, right? You can split your networks to subnets. You can have firewalls or security groups if you're running in the cloud. But that only, covers very basic needs in security. And that logic that is often implemented traditionally in services themselves, they would be there would be authentication and authorization, right? So my services need to authenticate against each other before they can access sensitive data, for example. And that is very time consuming and takes a lot of effort, especially on a large scale when you're running a microservices platform with hundreds or thousands of services, and you need to maintain same mechanism for authentication and authorization between your services. So with service mesh, it makes very simple to do that. So based on mutual TLS, the sidecar proxy will just do the authentication and authorization for you. So you can just set things up in the control plane, configure which services can have access to which other services, and it's done, right? So you don't need to implement anything, any logic in your applications. Then you also can have some web application firewall features, right? So of course, it's not, complete feature set yet. It's developing, I would say, but you can have some DDoS protection, and you can have some other like filters, web application firewall alike features from a security perspective. And what also you can have, and almost for free once you deploy a service mesh, is traceability and accountability, right? So you can make all the sidecar proxies log all requests. You can make them log unsuccessful authentication attempts. I hear there are problems with network, so I will try without video. And sorry for that. So you can, set things up very easily and have the traceability and accountability, and all these things in the area come almost for free when using service mesh, as compared to traditionally without service mesh, as they will take a lot of effort and time from your teams. So then, second most popular, I would say, based on my experience, my humble opinion, second most popular feature set is discovery and routing, right? There are many solutions to how discover your other services and how to use those. But again, that takes time and effort, right? Traditionally, you would implement that functionality in your service or application, right? So there will be some library that will use some external service for discovery, and then we'll have some logic to route requests to a discovered service, right? And again, by putting that sidecar proxy between your application and the rest of the world, you can outsource that functionality that will be transparent to your application. So your application just asks, send this request to service B, right? And it's just done, transparent for your application. And also this enables really advanced logic on routing. So you can do, very sophisticated routing algorithms. You can set up rules. You can do, let's say, blue-green deployments, rolling deployments, canary deployments very easily. You can route part of users to new application versions. You can even route specific usernames or groups to your service versions, maybe running in different clusters, right? So service mesh can span across multiple clusters in some cases. Yeah, yet another set of features is related to resilience. Is circuit breaking, right? So when things go wrong, you want to hit that lever and turn things off, right? So in cases when you have like situations with storming requests because of different reasons, right? But if your network is just overloaded, or you're out of other resources, maybe you're out of CPU or RAM or something, you cannot scale your services as fast as needed, right? So you just want to terminate all those requests, and which make sense. Nasty, right? Then retries and timeouts. So often happens that a request fails and you need to retry that. Again, that takes time and effort implementing this functionality in your service. But what if you can simply outsource this to the sidecar container, and that will do retries on your behalf as configured centrally. And then you can also do some chaos testing using service mesh. You can inject failures and delays when you are testing your application, right? So it gives you a lot of flexibility there. You can do ejection, right? So for example, you are running a service which is 3 instances of that service in your cluster, and one instance starts to generate a lot of errors for whatever reason, right? That just happens, and you can, with service mesh, makes it simpler to eject those failure-prone instances of your services from the serving pool and just start instances as needed. And you can also do rate limiting. So whenever you need to limit rate of requests to your service, and would be different use cases. For example, you can have a backend or third-party service that can only handle this much requests, right? So that if your service is making requests to some other service which has such limitations, then what you want to do is you want to limit the number of requests that your service can accept, right? But you want to do that in a way that will allow consumers to handle this. So you will just send pushback, and then the client can understand that rate limit exceeded and just try later. And again, all this takes time and effort to implement, and especially difficult to implement this using different languages, right, in a complex platforms. So Service Mesh just provides a simple way to unify all this. Also observability, right? So yet another piece that is critical when considering microservice platforms. So you need to gather metrics from all your instances, from all your workloads, and that's really difficult in a dynamic environment when you start and terminate containers or VM frequently, right? And you need access logs, and you need distributed traces in distributed system, right? It's nearly impossible to troubleshoot a distributed system without having distributed traces. And yet again, Service Mesh has that almost out of the box for you. So what is Service Mesh for? For network and traffic control, for advanced network logic, for security and observability, right? So this are the main groups of features that Service Mesh can help you with. But it comes with drawbacks, of course. As anything, nothing comes for free. So if there are advantages, should be disadvantages, other side of the coin, right? So it's added complexity. So it's another abstraction layer that you add to your infrastructure. You need to manage that. You need to take care of that. You need expertise, right? So you need skilled people who understand how to handle, difficult situations, and it's again increasingly complex to troubleshoot Service Mesh failures, for example. Scale. You need to plan carefully, right? You need to plan your Service Mesh deployment and rollout. You need to consider performance limitations. As you can imagine, having proxies next to each workload instance will impact performance, right? And it's not if here, right? It will impact performance. The use case that performance impact can be very different, but in general case, we're looking at adding like 2-3 milliseconds to your latency, and that is for each microservice, right? So if your microservice structure is such that you need, let's say, to call 5 other microservices in order to fulfill a request from a user, then you will be looking at 10 milliseconds of added latency. That can be significant for some use cases. And of course, it's not just latency, right? So this proxies will consume resources. They will consume CPU and RAM, and you need to account for that when planning your capacity. Then invasiveness, right? So this sidecar proxies are running paired with your services, with your applications, and they are running close to them. But This can be, a challenge for infrastructure deployment. So many service meshes have good automation for sidecar injection, but in other cases, if you want to deploy this on VMs or otherwise legacy infrastructure, this can be right. But even with Kubernetes, when sidecar injection is automated, then you will still need to plan for this, and you will need to find ways to test applications on local development environment, for example, right, and so on and so forth. So some complexities here, and of course adoption. So when you are adopting service mesh, there can be multiple challenges on this way, right? So you need to convince many people, you need to make substantial changes to your infrastructure, and not just how you deploy services and operate them, but also this might require changes to your login and monitoring infrastructure. This might require changes in your networks. So it's kind of, takes time and effort here. So when I was listing the features and saying you can outsource this and that to this sidecar proxy, to service mesh, basically, that sounds great, but this means actually that someone somewhere should be, taking care of this service mesh, make sure it functions correctly. It cannot go down, right? It should be processing your requests at pace you need it to process your requests. Should be transparent, but and the fact that it's transparent makes it kind of comes by default, right? Comes for free, but it does not come for free. So you need special attention to how you design and implement your service mesh solution for your project. Okay. And then let's see. Let's look at available service mesh implementations. So most popular and most mature service mesh implementations are Istio, Linkerd, and Traffic. So these three have started earlier, and they are around for more than 2 years each, kind of matured projects with great features. Let me just, okay. So Istio, Linkerd, and Traffic be your main choices if you're looking for open source service mesh. Then a proprietary option is Console Connect from HashiCorp. So that is also a great product, but I don't see that used in cloud native environment too often. So its use case is more towards hybrid environments when you are running part of your workloads on premises and you need to make those have access to your brand new container platform. And then Kuma is developing service mesh that builds on experience of others and avoids some pitfalls, but is not yet mature enough. So it's in versions 0.7 somewhere right now, I guess. So it didn't reach 1.0 stable version just yet. So if you are looking at this, you will see that most features, most critical features will be supported by most service meshes, right? And most of them will use Envoy as a proxy. So Envoy is a piece of software that is used as that sidecar proxy. Great piece of software, just out of scope of this talk. And some will use their own proprietary proxy solutions, right? So Envoy is increasingly popular, and service meshes relying on Envoy as a proxy will have more or less similar feature set, just because those features are supported by Envoy, right? And all service mesh needs to do is to implement this feature in a control plane, so that control plane can manage new Envoy APIs, right? Can leverage those new APIs. So all service meshes represented here will have support for hybrid environments, meaning that you can span your service mesh across your VMs and containers. So you can have part of your services deployed in Kubernetes, for example, or other container platform of your liking, and then you can have other services running on VMs or bare metal, and they should still have access to the services running on container platform, right? So there is support for that. All five represented here will have MTLS support, will support TCP and HTTP 1, HTTP 2, gRPC. If you are looking at UDP support, then your choice of service mesh implementations, is more limited. So I would expect all of them to have UDP support occasionally, but perhaps just not yet. And all of them will support tracing and circuit breaking and retracing timeouts. And some will support also fault injection and rate limiting, right? So mostly this is, if you will be choosing a service mesh, you will need to go deeper into details of those features and understand how exactly given service mesh fulfills those features and what exact capabilities will be there, right? Because here on a high level, it looks like, for example, all 5 service meshes will support tracing, but not all of them will support all tracing backends, right? So some will support open tracing, some will not. Some will support Jaeger, some will not, right? So if you have some requirements on that, if you're already using some solutions for distributed tracing, you will need to go deeper, right? And the same applies to all other features here. And of course, there is more than this. So service mesh landscape is much broader than just 5 implementations I have listed on this slide. There are implementations from AWS and from Microsoft, and there are other less popular and emerging service mesh implementations. So just have a look. Right, so that's it for the talk, I guess. I have all the resources here where you can get more details on service meshes I showed on the slides. You can go through their docs, explore their features, and I guess I saved some time for questions. Do we have questions?
Thank you, Dmitry. Thank you, Dmitry, for such interesting speech. Of course, we have a lot of questions from the audience. And yeah, let's start from the question from Matteo Battini. How can you measure the performance for the service mesh?
Okay, and that's a great question. So there are performance benchmarks specifically designed for service meshes. I would love to give you some links. I will actually share some links after the talk. Can we do that? Yeah, I got.
Yes, if the question is very complex, I suggest to move the discussion to the portal.
Yeah, I can give general answer. So how you can measure the performance of service mesh. So you need to have your test application, and you need to put some load on that, right? When it is deployed to your environment where you also have service mesh deployed. So once you do that, you can measure the impact of service mesh on your application performance, right? So you can run same application with and without service mesh, and also it would be advised to also run service mesh with different features enabled, right? So you can enable and disable features, and depending on features, there also can be different impact on performance. So you just run your application with and without service mesh, with and without features, measure your latency, your throughput, your resource utilization, and that's how you can understand the performance impact of the service mesh.
Right. Thank you for your answer. And I already asked the author of this question to put it into the portal as well to continue the discussion offline. Right. And the next question will be from Arrest. Do we need to implement service mesh in every possible cases, or it depends on some reason? Why are they? What are they?
Great question, Oris. Thank you. So, of course, it depends. There is no silver bullet in I would say, in a broader technology domain, right? So, whatever subject is concerned, there is no one single solution that will fit all, right? So, if you are looking for to have features I just listed, then you can think of deploying a service mesh or adapting a service mesh, right? If you are on maybe old school monolithic application, probably you cannot benefit much from service mesh, but still you can have some benefits, right? So it's the problem you are trying to solve. Understand that first, and one of the solutions to your problem might be service mesh, but might be not, right? So it's really there is also some overlap in service mesh in terms of features with other technologies like API gateway, like service discovery, right? So if you need service discovery, service mesh is not the only possible solution, right? So that's what you need to consider when deciding if you need to implement service mesh or not, and try to understand your business problem first, and then come up with a solution.
Okay, thank you for your answer. And let's move on to the question from Oleg. Should control plane be considered SPOF? Should service still work if it fails?
Right, yes. So the design of a service mesh allows operation to continue if control plane failed. That's true. So control plane is not used to transfer your data. It's just designed to control your sidecar proxies, right? So if your control plane fails, then your system is still functional, all your proxies are still processing your traffic. It's just you not push new configuration updates or other changes to your fleet of proxies. Yeah.
Right, and some more questions from Matteo Battini. Hybrid environment support also works to manage communication among different cloud providers as a multi-cloud solution.
Good question, Matteo. That is possible, but you need to be very careful with that. I mean, technically it is possible, and if you look at solutions like Google Antas and Azure Arc, you'll see that they try to do, they suggest you to use service mesh in a hybrid environment in terms of geographical locations, right? So if you have your on-premise data center and then you have your cloud provider, you can run one single service mesh across all your infrastructure, right? But this can become really expensive if you don't do your routing policies right. So if your traffic will go through this expensive link between your different cloud providers or from cloud provider to on-premises without a good reason, this can become very expensive. So what is recommended here is to partition your service meshes as much as possible to avoid cross-location traffic when it's not really needed. And also, so you can have, several independent service meshes, one for each cloud provider, and you can have some interconnection between those as a first option, right? And as a second option, you can have one single service mesh to span across your different cloud providers. So I would say that first approach was two separate service mesh segments running for one for each cloud provider is recommended by default, and the other, when you span your service mesh across several providers, is something that you need to be very careful with, just because cost of that can go out of control.
Okay, thank you, Dmitro. And Anton would like to know, service mesh required a huge amount of proxies. Will this affect delays?
Well, not the right word here, I guess latency, right? I was speaking about latency on one of the slides. So yes, it will. Short answer, yes, it will. I mean, it's not a question of if. Yes, it will. How much depends on the features enabled on your proxy. So if you have, let's say, just a simple configuration when you just need to route requests, that is, going to be faster as compared to when your proxy is also doing metrics and monitoring and tracing, right? So that all takes time. And even though your proxy, can handle more requests, it's often can be limited by number of workers on that proxy, right? So have flow of requests coming in. Usually you have limited number of workers on your proxy server, right? And every worker will be blocked until it finishes the processing of a given HTTP connection or whatever the protocol you're using, right? So in some cases, later you can go as much as 10 milliseconds up for each request to each microservice. That really depends on the features you have enabled. But yes, it will have the performance impact.
Thank you. And one more question from Arrest. Looks like Arrest is definitely trying to get the prize for today. Are there any good choices besides Istio?
Yeah, so both Linkerd and Traffic are solid choices. Good mature products, people use those in production for years now. So you just need to look at the features before you make a decision. Istio, yes, Istio is becoming increasingly popular and is being promoted by many big players such as Google, IBM, and some others. But if you ask my personal opinion, I don't like that Istio is not fully community driven. So it's more of those large companies who define the direction of future development, right? And Google uses Istio in Google Cloud. And as far as I remember, IBM is using Istio in their cloud solution, right? So they will be focusing on features they need for Istio and not for and will not be focused on features you need, right? So as a customer of Google and IBM, you can consider that they're working on the features you need. Linkerd, in the country, is managed by Cloud Native Computing Foundation as an open source community driven project, and I like that model more. But personal preference, but again, all three are solid, stable, mature service mesh solutions.
All right, and we just got a new question, in my opinion, it's very interesting question from Satish. If service mesh is hacked, hope it is not, then how to identify it was hacked?
Yeah, well, it's hard, I guess. So again, depending on which level it is hacked, right? Hacked. Okay. So if you have a mutual TLS enabled service mesh, then if someone with bad intentions only got access to one instance of service running, then it will only have access to the services where this service has access to, right? You need to manage your permissions, and you need to limit the blast radius, right? Just like with any other infrastructure related technology. How do you identify that? I guess same tools as you would use to identify that you have that security problem. Someone has access to your systems. So those would be traditional solutions like Snort, if we're talking open source, right? And you will put that on your Kubernetes work kernel, and you will be monitoring specific patterns. Yeah, I guess that's how.
Okay, thank you. And one more question from Matthias Kovac. Let's say you have an application that consists of 12 microservices and you would like to take advantages of service mesh. How would you start using service mesh? What would be the first step of the implementation?
Okay, So first step is to try that, right? So, I mean, if I was to start using Service Mesh with 12 microservices is, relatively simple system nowadays, as compared to, hundreds and thousands of microservices. So for that scale, I would say just try it out. I would imagine you have some non-production environment, or can set up a non-production environment relatively easy. So just do that and try it out. Most service meshes will have automatic injection of that sidecar. So once you have your non-production environment ready for testing, you just deploy a service mesh of your choice, and you should be able to make that work relatively easy. So just try it out, then show the advantages and the gains in terms of developer experience to your team, get them excited, and plan the release to all your environments.
All right, thank you very much. I'm looking through the questions once again, but looks like everything already answered. So thank you very much for the session, and this is the best time to nominate the best question from the day.
So you want?
Yeah, unfortunately, the one question was removed from the main regarding this POF. So maybe you can choose right now and nominate the best question.
So I like the question about if I need to implement service in a possible case, and I also see it has most votes on it. So that is the best question for today from Orest.
From Orest. All right. Okay. So Orest, congrats. Looks like you win the prize. Thank you very much. So Dmitry, thanks again for to deliver this great speech. And would like also to remind the audience to put their questions, if still some, to the portal, and Dmitry will answer with the pleasure. And once again, have a good day, have a good evening. Thanks for being such an active audience, and stay safe. Wash your hands. Cheers. Bye-bye.
Bye guys. Thanks.